This time we are going to discuss also on how to compute the t-test using the dependent samples using means. This is another statistical test under parametric test. If we want to know whether there is a change of the data set from the previous group to another group, we call this dependent samples because it assumes that the data was taken from the same respondents, but the data was taken at different times. Usually in the educational setting, example for those who are studying whether the approach, the program, or the strategies implemented by the teachers to the students is effective or not effective, or how effective that is, whether it gives changes to the score of the students, then this test will be used, the test for dependent samples. Usually what happened then is the teacher will administer the strategy to the student after the pre-test conducted. And then after the administering of the strategies, then the post-test then will be conducted. And so if there is an increase of the score, then that is due to the strategy implemented by the teacher. However, also if we consider the data from the field of business, for instance, usually this happen before and after. Example, before the promotion strategy was implemented, how much was the sale, and then after the promotion strategy was implemented, how much then is the sale. So it's a comparison of the sales for the owner of the business to know whether the promotion strategy was effective or not. And so we need to understand how to use the t-test for dependent samples, considering again that the data, two data set are taken from one single participants or group of participants. Okay, so example for the t-test is, this is the formula. We have here the t is equal to the bar d minus mu d over sd over square root of n. The bar d is the mean of the difference because you have to get the difference of the score before and after, or the pre-test and post-test. And then the mu d is the difference assumed from the population. But if the mu d, or the difference in the population, is not given or not known, so we assume this as 0. So that's why sometimes we will use only the bar d minus 0 over sd over square root of n. Now, the sd is the standard deviation, wherein you have to consider the standard deviation of the difference of the data set from before, after, or from previous, or the before, after, or the pre-test and post-test scores. So you have to understand that again, that d is the difference of the scores between the two set, and the sd is the standard deviation, and the formula is the square root of n times summation of d squared minus summation of d squared all over n times n minus 1. This is the formula for the standard deviation if you do that manually. And then bar d is again the average of the differences. So you get the sum of the differences, and then you divide it by how many respondents under study. So we have to consider first also the same with the other statistical tests for parametric, that there are still assumptions to be considered before we administer the t-test. If the assumptions are not met, then we will use the non-parametric test corresponding to this t-test for dependent sample using means. So assumption first is, again, the data is normally distributed, or the data set is less than 30. And the variance is known. Of course, we can compute that using the numbers given. Example here, this is an example problem wherein usually this problem is reflected in the research output. So is there significant decrease in the grades of the students after the change of the new instructor in the subject? So meaning, does it mean that if you are a new teacher, it changes the score? So before, what is the score, and after? So you may not think of the new instructor, so you might think, is there significant decrease in the grade of the students or increase? So let's think of increase. Increase in the grades of or scores, say scores of the students after the implementation, after the introduction of new strategy by the teacher. So meaning the teacher implemented a new strategy which the teacher thought that is effective for the students. And the teacher can only say it's effective if it gives significant change of the score. So that's a comparison before and after. Okay, so what happened? There is a conduct of pre-test and post-test. So pre-test, then implement the strategy, then post-test. So we still use alpha level 0.05. So remember, we are now using the word increase, so meaning it's one tail. Unlike in the previous example, we use difference, so it's two tail. So this time in the table, reference table, we have to use the one tail because of the word increase. Now, we are expected to identify the variable, the mean of the two groups, the variance, the sample size, the t-test result, critical value, the decision, and the interpretation. Now, again, we are going to use the practice of testing the normality from the as reflected in the book of Blumen. The PI, or the Pearson index, which is 3 times the mean minus the median over the standard deviations. And then, okay, so the mean refers to the mean of the difference. This time we have to get the difference first, and then we subject that to test of normality, not the individual pre-test or post-test. And then we will get now the uh, PI, and then that will be analyzed whether the data is normally distributed or not, if it falls between -1 or +1. Okay, so let's have an example for us to really understand thoroughly. So example, this is the column of the students. So in this case, we are using 22 students. And then we have the score of the students, 50 points before the strategy implemented. So meaning this is the pre-test, or the pre-test. And then we have the score of the students after the implementation of the strategy. This is the post-test, somewhat like the post-test. And then we have the column, the difference. So D is the difference, simply subtracting before and after. So if you notice in the formula, you subtract 15 minus 35. So the answer is, it's in here. We have to do the opposite. So equals 15 minus 35. So it's -20. So it's -20, meaning there is significant increase. I mean, there is increase of score from 15 to 35. So 20 points. Okay, so that's the change. Now, there are also scores, if you notice. From 16, it lowers down to 12, so there is a change of 4. And then 35 to 28, there is a change of 7, and so on and so forth. There are also scores that are the same, so there are no changes. Okay, so our target now is to analyze whether there is significant change, increase of the student score before and after the implementation of the strategy. Okay, so by formula, if you remember, we have the D now, the difference. So what is lacking is we have to get the D squared. The D squared is simply the multiplication of the D value by itself. So you have to do the command equals -20 times the asterisk, click it again, and then enter. And then double click. So make sure to find the black cross below the number, or the within the grid line corner, and then you have to double click. So these are now the squares, the D square. Now we have to consider these values in the analysis using the formula of t-test using dependent samples. Okay, first we have to test the normality. The same idea with the Pearson index. So we will get the average of, or the mean of the D. Okay, so all the scores under study. Enter. And then we have to get the median of the difference, because the data that we are under analyzing is the difference. So not the pre-test, or not the score before or after per se, but it's a difference in the formula if you look at it. And then the standard deviation equals ST dev that S. Okay, so double click this one and then highlight again the difference. Enter. And then PI is, if you remember, that is open parenthesis 3 times you subtract the mean minus the median, then close that parenthesis, and then divided by the standard deviation. So it's 0.22 according to the Book of Blumen. It's between the range -1 to +1. So we can say it's normally distributed. So therefore, it's normally distributed. Now, what statistical test to be used? We can now use the t-test for parametric test. Using this formula. If it so happened that it was not normally distributed, then we will not use the t-test. But in this case, we will use the t-test. So we are now free to use the formula. Okay, in order to complete the needed data in the table, so we will use now the formula. So first, as you notice, you have here the body. So mean of difference. So we will need the mean of difference. And then we have the mu d. In this case, we are not given a mu d, meaning the difference of the population. So we will assume it's 0. And then if you notice, you have here SD. SD is actually referring to the variance. I mean the standard deviation of the difference. So you can say SD. Okay. And then so again, this formula is the standard deviation of the difference column. So that's SD. And then bar D is actually the mean of the difference. So we simply add the difference divided by how many all in all. So the mean of difference is equal to, so you get the sum first, or you can say average. Average equals average of the difference. Okay, so you highlight all the values. It's -10. So the same here. That's the mean or the average of the difference. And then what we need now is the SD. So again, that is standard deviation. ST dev.s. So you can also do that manually. However, we can use the shortcut command in the Excel. So stdev.s, then highlight again. Okay. And this is now the standard deviation. I think we have here already in the test of normality, but we are using what is needed in the formula. Okay. So our N actually sample size, if you notice, we have 22 students, so we can write that 22. That's our sample size. So what will happen now? We will now subtract. I mean, since we have the no value for mu d, we assume that 0. So we have the bar d, which is -10.13636364. Divide it by the quotient also of the standard deviation over square root of n. So first we have to get the square root of n. So meaning you have the command equals sqrt, open parentheses, our n is 22. Enter. So therefore, our t value now, our t test value is equal to, so how do we do that? That is equal to, you have to first, no, before the t test value, we have to get first the quotient. So meaning SD over square root of n. That means you have to divide first the mean difference, I mean the standard deviation, divided by square root of n here, 4.69. There, that is the SD over square root of n. So that's the formula here. SD over square root of n. So we are done with this. So this is the divisor of bar D. So meaning we can get already the t-test. The t-test value now is equal to, so the bar D, which is the mean difference, over, okay, so if you notice SD over square root of n, so meaning after we divide this, that is the new divisor. So referring to that value. And the t-test value is -4.16. Okay. Okay, so it's -4.16. That's the t-test value. Now, if you look at now in the summary table, we have the t-test value. We need the critical value, the decision, and the interpretation. So let's try to fill in here The variable actually is the score of the students. Scores, scores of the students before the implementation of the strategy. And then we still have scores of the students after the implementation. So let's make it shortcut like that. So what's the mean of the score before? So we will go back to our data. So in our computation, okay, so equals the mean of the score of the students before. All right. Okay, so I think we have not computed that. It in a way it was not needed in the analysis, but later we will just compute, or we will just what we will do now is we are going to uh, get the mean before, so get the average of the scores before, and then we will get also the average of the scores after. So you'll just carry that here, and this is now the average. So we can write the mean of the scores before is 20.222, and then the mean or the average after is 30. So as you notice, there is a possible increase. It's 30 from 20 to 30. Okay, so what's the variance? I think it was not needed in the formula, so we will not consider the variance, so we will not just delete that. Okay, so we will just delete it. Okay, I'll make it black so it will not be counted. Okay. So sample size, since the data is subjected together as one, so we will not consider that analyzing. And then we will now use the t-test. So the t-test result based in our computation is -4. Okay, so what we need now is the critical value. So since our degrees of freedom is n minus 1 also, so that means you have to uh, go go to the table and look for the value for the degrees of freedom n minus 1. Our n here is 22, n minus 1 becomes 21. So we go to the t distribution table. So we'll go to the table, we'll find the table in the internet. So we'll say t distribution table. Okay. Okay, and then we'll go to, okay, we'll try this one and we'll visit to the statology table. Okay, so in this case, what we need is we are going to look for a table that is, okay, t distribution. Okay, let's have here, yes. Okay, so this is a t distribution table. All right, so as you notice, there are t values here. It's one tail and two tails. So we'll go to, again, because of the word increase, so it's one tail. So we'll go to one tail 0.05. It's in here. And then you go to 21. So 21 is in here. So it's 1.721. So one tail again because of the word increase. And then it's 21 because n minus 1. 22 in the example. And then we'll have 21 as df is n minus 1. So 1.721. So this becomes 1.721. Okay. It was positive in the table, but since the t-test value is negative, so we can also assume that it's negative. It's one tail going to the left. So what happened? We noticed that the t-test value, so the t-test value is beyond. So the t-test value is beyond the critical. If you look at the number line, so if you recall number line, we start with 0. So at the center is 0, going to the left is -1, then to the right, again to the left is -2, and then, okay, and so on, -3, -3, and then -4, and then -5. So in this case, the critical is just in it's in the negative 1.71721. Okay, all right. So it's left tail. So it's in here. It's negative 1.7 somewhere here. But then our t-test is somewhere here. So we know that that is beyond the critical value actually. So considering its distance. So therefore, it's significant. So we can say it's significant, and then that means our null hypothesis is rejected. So what does it mean? There is significant increase. So that means after scores greater than before. Okay. Okay, so that means the scores after are greater than before, which if you compare, if you go back to the data, the mean before is 20 and the mean after is 30. So therefore, there is a significant increase of the score. So perhaps by that analysis, we can say that the teacher's strategy used was effective because it gives change to the score of the students. However, there are still other factors to consider really the effectiveness of the strategy by doing other experimental classroom tests. Okay, so I think that's all. Thank you.